Hey, class, this is lesson 312, percents and proportions. So we're going to learn how to use proportions to solve percent problems. I just want to quick summarize what you learned in the last lesson there. Suppose you are calculating p% of 1,000 and p% of 700. Which would be a greater number? Explain your answer. Well, p could be any percent, and it's the same for both. So let's just say make p 50. So which is greater, 50% of 1,000 or 50% of 700? Well, obviously 50% of 1,000 is more because it's out of a bigger number. So the greater number is always, if you're taking the same percent, the percent out of the bigger number. So number 2 says, which represents a greater percent, t out of 1,000 or t out of 700? Again, let's just pick a number for t. And I'm going to pick 1,000. So which is a greater percent, 1,000 out of 1,000 or 1,000 out of 700? Well, 1,000 out of 1,000 is 100%. 1,000 out of 700 is greater than 100%. Because the numerator is bigger than the denominator in this ratio. So this is plus 100%. So if you're taking a certain number out of two different numbers, whatever you're taking, if you're taking it out of the smaller number, that's going to be a greater percent. All right, one way to work with percent is to set up and solve a proportion. And a proportion, by definition, is just two equal ratios. So like 2/5 is equal to 4/10, that's proportion. 1/3 is equal to 30 out of 90, that's proportion. When using the percent proportion, you will know two of the three values. So this is the percent portion we're going to use. We're going to think of the B as the part, the A is the whole, and the percent is N. And I'll show you in a little bit how you can use that proportion like that to find the answer to percent problems. Use the percent proportion exercise 6 to compare the values of A, B, and N. If B is less than A, then the value of N is less than 100, so less than 100%. If A is less than B, then the value is greater than 100. And if A equals B, then we have 100%. All right. So again, just like last time, I'm going to do some of the problems, and then I'm going to skip some others. So whichever ones I skip, we'll do in class. So for this first problem, I will do A with you. What percent of 2/3 is 5/6? And I'm not going to use proportion or anything fancy here. I just want to think about this and see if I can reason my way to an idea about what this is. I'm going to use a diagram here of 2/3. So if I color those two parts, then I've colored 2 out of 3 parts. And I want to know what percent of that amount, 2/3, is 5/6. So I'm going to show another diagram with 5/6. And 5/6, I can start by starting with 3 parts and then splitting each of those 3 parts in half. And now if I color all this, I have 5 out of 6 parts. Now, if we look at 2/3 in relationship to this, we see that 2/3 is the same as 4/6. So when it says what percent of 2/3 is 5/6, we can see that 100% is right here. And so 100% is right here. And besides that 100%, we have an extra part. That extra part is 1 out of the 4 parts. 1 out of 4 is an extra 25%. So 5/6 is 125% of 2/3. 2. So here it says the circles show 30% of the figure, and it says draw 100% of the figure. And then it says draw 150%, and what percent of the figure is one circle. All right, so I'm going to do part A, and then I'll let you think about parts B and C. And if you need help, I'll help you with that in class. But I'm going to use my little hand camera here and take a picture of 2 of these. And I'm going to use that so I can redraw real quick. So as many as I need. All right, so this is 30%. Well, I'm going to split that 30% up into 10 plus 10 plus 10%. All right, so each of those 3 parts is 10% of the figure. So 3 tens makes 30%. So 2 of those is 10%. So if I want 100% of the figure, I need 10% 10 times. That makes 100. So I'm going to add on. There's another 10. Now I have 50%, 60, 70, 80, 90, 100%. All right, there's 100% of the figure. And I needed 20 parts, 20 circles to draw that. All right, so think about what would 150% of the figure look like, and we'll work on that in class. All right, Anna's making lemonade for a party. The lemonade will contain water and at least 75% juice concentrate. Anna has 6 gallons of concentrate. What is the greatest amount of lemonade Anna can make? So, just a quick picture. If each of these diagrams represents a gallon of concentrate, all right, so this is 1 gallon, 1 gallon. So, and this has to be 75% of the, at least 75% of the juice concentrate. So, if you think about that, 75% is 25% 3 times. So I could think of 2 of these as being 25%. And that makes 75%, which means I need 2 more gallons to make up the entire amount to get that 100% of my juice. So another thing we can do, though, is we can set up a proportion to represent this. If we can think of what numbers do we know about this situation and what do we need to find, we know that we know the percent here. We know that the concentrate is 75%. So you can see here in this proportion, the percent goes over the 100. And we also know that that concentrate is part of the whole lemonade mix. So it's not the whole, it's the part. So this, and we want that to be 6 parts. So 6 parts out of the whole, 80 in the whole, makes up this proportion. Now, once you have that, you can solve the proportion. And I think you've learned some ways to solve it in the past. I'm going to rely on a certain way that I think is easiest and best represents proportions. Just a quick lesson. Back when I was introducing proportions, I showed a couple of sets of equal ratios that make up proportions right here. There's one thing I want you to notice about these proportions. Now, if I multiply 2 times 2, I get 4, and if I multiply 5 times 2, I get 10. I can use that idea if I want to solve it. Same with this one. I can take 1 times 30 to get 30, and 3 times 30 to get 90. That's one thing that's true about proportions. But another thing that's true that I like even better for solving proportions is that the cross products, meaning if I take the 2 and the 10 and multiply, and I take the other numbers that are across from each other, the 5 and 4, and multiply those, they will equal each other. And that's always true with proportions. So in this proportion, 1 times 90, 1 times 90 is equal to 3 times 30. Now, here's how we can use that to solve a problem. So I have the proportion 6 divided by A equals 75 divided by 100. Well, the cross product, so 75 times A has to equal the other cross product, which is 6 times 100. Now I can simplify that. 75 times A is equal to 600. And I can finish solving this by dividing 600 by 75. And I get A equals 600 divided by 75 is 8. That's a quick way to use the properties of proportions to find an answer using the cross products. All right, so let's try again here. So here we have a diagram, and it shows on this diagram that 120 of 200 total is filled up. You could think of this as a glass, and maybe there's 120 ounces filled out of 200 total. And we're wondering what percent that is. So thinking about our proportion where we have part, B is the part, A is the whole, N is the percent out of 100. And this diagram, the N is missing, so we don't know that, so we're not going to put any value there for N. The part is 120, it's 120 filled up out of the whole of 200. So the part is, B is 120, and A is 200. So if I put 120 where B is, and 200 where the A is, and leave the N where the percent is out of 100, then I'm going to use cross products to solve that. So N times 200 is equal to 120 times 100. If I simplify that and solve it, so 120 times 100 is 12,000. And divide by 200, and I get N is equal to 60. So 60% is the same as 120 out of 200. Now that kind of makes sense because 120 out of 200, if I divide those by 2, I get 60 out of 100. And when you have a ratio out of 100, that's a percent. The top number is the percent. All right. At the pause this will be part 1 of lesson 312. You can view part 2 after this.